So this is numerical type question, and this question is taken from the chapter continuity and differentiability. So here domain is also defined from minus pi by 2 to pi by 2, and function is given mod x plus mod x minus 1 sin x box of x sin x. Here box represent greatest integer function. So they are asking about the continuity and differentiability. They are saying that the number of points where this function is discontinuous is alpha, and the number of points where this function is discontinuous from minus pi by 2 say pi by 2 to is beta. So what is the value of alpha plus beta? So first we will try to find out the number of discontinuous point, then we will see for the non-differentiable points. So for discontinuous points we have to check for this function. This is given fx equal to mod x plus mod x minus 1 sin x plus box of x sin x. So if we break this function, then we can see easily that this function is continuous everywhere. This is also continuous everywhere. This is also continuous everywhere. So this function is continuous. Now we have to check for box of x sin x. So suppose we are considering gx equal to box of x sin x. So we have to check in box of x sin x, how many points is there in which box of x sin x is discontinuous, because mod x and mod x minus 1 into sin x is continuous everywhere. So if in this function there is any point where this function is discontinuous in minus pi by 2 to pi by 2, then definitely this box of x sin x is contributing in that point. So we will try to draw the graph of box of x sin x. So first we will consider x sin x. So hx equal to x sin x. We will differentiate this function. So h dash x sin x plus x cos x. Now we are trying to draw the graph of x sin x. After that we will apply the box, greatest integer function. But first we will try to draw the graph of x sin x. For that we should know the nature of hx. So h dash x is greater than equal to 0, in which hx will be increasing. So it is greater than equal to 0 for x belongs to 0 to pi by 2. And h dash x is less than 0 for x belongs to minus pi by 2 to 0. It means hx is increasing from 0 to pi by 2 and h dash x is decreasing from minus pi by 2 to 0. And at pi by 2 we are getting the value of hx is pi by 2. And at minus pi by 2 also we are getting the value of hx is pi by 2. So the graph of this hx is going like this. Pi by 2, at pi by 2 we are getting the value of hx is pi by 2. Similarly at minus pi by 2 we are getting the value of hx is pi by 2. So now we know the nature of this function hx, that is 0 to pi by 2 this function is increasing and concavity is upward, because f double dash x is also greater than 0 in 0 to pi by 2. And also in minus pi by 2 to 0 also h double dash x is greater than 0. So concavity is upward. You can check h double dash x. Now we have to apply the box greatest integer function in hx. So when we will apply, we can see that we will get at 1 at any particular value of x1. At any particular value of x1. So this white color is the final graph of box of x sin x. So we can see that that at these 2 points x1 and minus x1, this function is discontinuous. So this is discontinuous at 2 points. 2 points. So fx is discontinuous at 2 points, that is x1 and minus x1. So value of alpha will be 2. Value of alpha will be 2. Now we have to check the number of non-differentiable points. So check. fx is given, box x plus box x minus 1 sin x plus box x sin x. So we know that box, if we break this function, so we can say that mod x is non-differentiable at x equal to 0. But when we will multiply with sin x, it will become differentiable at x equal to 0. Mod x minus 1 is non-differentiable at x equal to 1. And box of x sin x is also non-differentiable at 2 points where it is discontinuous. So total number of non-differentiable points is 3. So alpha plus beta is 2 plus 3 equal to 5.